Solve the problem. Andrew and Kent do desktop publishing. Kent can prepare a certain prospectus 2 hours faster than Andrew. If they work together, they can do the entire prospectus in 5 hours. How long will it take each of them working alone to prepare the prospectus? Round your answers to the nearest tenth of an hour. Well, we've performed step 1. We've read the problem carefully. Next, define your variables. Let X represent Andrew's time working alone, and let's let X minus 2 represent Kent's time working alone. We're given that Kent can prepare this prospectus 2 hours faster than Andrew, so his time amount is going to be smaller. Now let's make note that this is a work, rate, and time problem. So write down the equation W equal RT. Let's use a table to organize our information. If Andrew can perform this job working alone in a time of X hours, then his rate is 1 over X of the job per unit time. Kent's rate correspondingly is 1 over X minus 2 of the job per unit time. We're told that they can complete this job together in 5 hours, so their time value is 5 each. And the amount of work done by each we get by the product of R times T. 1 over X times 5 is 5 over X. Product here, 5 over X minus 2, and together they're going to complete one entire job. We're going to use this column to write our equation. So the amount done by Andrew, 5 over X, plus the amount done by Kent, 5 over X minus 2, is equal to one complete job. We've completed step 3, we've written our equation. Step 4, let's solve this equation. Multiply by a lowest common denominator, X times X minus 2, to get rid of our fractions. Multiplying times our first term, the X's cancel, leaving 5 times X minus 2. Multiplying times our second term, the X minus 2's cancel, leaving 5X. On the right side, we have X times X minus 2. Now let's solve this resulting equation. Distributing, we get 5X minus 10 plus 5X is equal to X squared minus 2X. Here we have a quadratic equation. Let's put it in standard form. I'm going to move everything to the right-hand side, setting that equal to 0 on the left-hand side. We have this term X squared. On the left, we have a combined 10X. Subtracted over, negative 2X and a negative 10X is a negative 12X. And let's add that 10 to both sides as well to get a plus 10. Now, let's use our quadratic formula. So X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. Let's substitute values. So we will have a negative of negative 12 plus or minus the square root of negative 12 squared minus 4 times A, which is 1, times C, which is 10, all over 2 times A, or 2 times 1. This gives us a 12 plus or minus. Underneath that radical, we've got a 144 minus a 40, that's a 104, all over 2. That 104 is 4 times 26, so let's simplify that a little bit and write this as 12 plus or minus. Square root of 4 is 2, that comes out. 26 stays underneath. Lastly, let's simplify by dividing that 2 into both terms and writing this as a 6 plus or minus the square root of 26. Now, we wanted to write our answer in hours, rounded to the nearest tenth. So let's use our calculator and clean these up a little bit. This 6 plus the square root of 26 is approximately 11.1 hours. Now, 6 minus the square root of 26 That's approximately 0.9 hours, and we've got a problem here. If x is equal to 9 hours, and remember that's Andrew's time alone, then x minus 2 is going to be a negative number. We can't have a negative number for Kent's time. So reject that as a possible option. However, the 11.1 is going to check out. So let's summarize and write our answer very clearly then. Andrew's time is 11.1 hours, and Kent's time then is that 11.1 minus 2, that's 9.1 hours. We've summarized our answer very clearly. I'm going to leave this one for you to check. You can check those in your original equation, and you're going to get approximately a true statement. Remember that we've rounded those off. Andrew's time is 11.1 hours. Kent, 9.1 hours.